Hi, you guys. In this video, I'm kind of trying to help you look at some proofs and see what kind of strategies they're going to ask you to do. So I'm going to give you hints as to how to solve these. You will get the hang of it once you start doing some of them. You'll see that they kind of follow a similar pattern. So what I want you to do first is copy this down on your own paper. Just do it. Don't be lazy, just do it. It is seriously one of the best things you can do. You copy this. Wow. Let's try this again. Okay, I got that. And I come down here, that, and then here. Okay, that's kind of ugly. I'm going to select it and move it. Okay. And move it and move it. Okay, I can't really move it. Dang it. Okay, whatever. Okay, I'll just try again. Okay, good enough. All right. So copy this on your own paper like I just did. You can see it doesn't take much time at all, and it's very good practice to try to understand shapes anyway. Then what you want to do is you want to look at your given and you want to mark up your drawing. Okay, it says ABC is congruent. Here's ABC, mark it. It is congruent to DEC, DEC. There you go. So now they're giving you one angle. So you now have angle. Okay, then it tells you that BE bisects AD. Okay, bisects. Now you should know angle bisectors or segment bisectors. If you have a segment, okay, and you have something that bisects it, you are cutting it into two equal pieces. Okay, so it says BE. Here's BE. Ugly E. BE. It's even uglier now. Okay, BE bisects AD. That means it cuts AD into two equal pieces. It doesn't say that BE is bisected. It says BE is cutting. It sect means to cut, like sections. Okay, you're cutting things into sections. Cut by means to. Okay. Prove that ABC is congruent to DEC. All right, so how are you going to prove it? So really, they're going to give you two things, and you're only going to have to come up with another. Okay, and it's going to be pretty easy because what you have is an angle and a side. You only need one more thing. Okay, so what they want you to realize is that you have vertical angles. This is going to be the one statement that you have to make in the proof. Okay, it will start with the givens. It'll say these two givens, and then what it's going to do is it'll give you the angle. So one will be like angle ABC is congruent to angle DEC, and the reason will be given. Then two will be BE bisects AD. Okay, then that's going to be given. Now, what they haven't given you, and you do have to state, is you have to state what happens because, see what I did? You remember that I actually wrote these down? I created these marks because I said, oh, bisects means cut in half. I have to actually state this, okay? For number 3, this is what you're going to have to put in there. You're going to have to put AC is congruent to DC, okay? DC. I lock these down. Hang on a second. Okay. Okay, and then that's going to be definition of segment bisector. Basically, you're only using the word. So you use this bisects, you're taking this word, and it's feeding that definition, okay? And then you have to state the angles, okay? Now, you can't say angle C and angle C, guys, because that doesn't work. You're going to have to use 3 letters. So we're going to have to say something like, because I did it, I'm going to have to state this. The marks that I make are the things I'm going to have to add to the proof. Okay. Angle ACB is congruent to angle. So I put ACB, so that's DCE. Okay, make sure you do the corresponding parts, okay? 4, and that is because of definition of vertical angles. Okay, so the only thing we're using is definition of segment bisector and definition of vertical angles. And now, what can I use to determine if these are congruent or to say that they are? Okay, what can I use? Start around. What do I have? I have angle, angle, side. Okay, angle, angle, side. So what's my last step? It's going to be triangle, and you want to do this. You want to put it in the order that they gave to you. So triangle A, B, C is congruent to angle D, E, C. Why? Because A, S. All right? So basically, they're going to give you a little bit, and then you're going to have to figure out from the information they give you what else you can add to that to get a theorem that you recognize. Okay, so take a look at this one. It says proofs involving segment or angle bisectors. Okay, so now we're looking at an angle bisector. Remember, bisect cuts an angle in two. So use the given information to prove that these two triangles are congruent. Look, A, D, B, C, D, B. One hint I could give you is to take these out. You don't have to separate them. For some people, it might help. For me, it actually won't because I want to keep in mind that they share a side. Wow, I thought that would fix itself. Okay, there it goes. A, B, B, C, and D. All right, so ready? Redraw it on your paper. Then you want to mark stuff up, okay? And you're not going to have to write these proofs, but I do because I don't have access to the page that you guys do. They're going to be partly done for you, and you're just going to have to select things. Eventually, you are going to have to be writing some of this. So I think you might have to write the extra stuff. We'll see. So AB is congruent to BC. They're giving that to you. So just mark it. And okay, we're just going to mark it. I'm actually going to mark it in purple because they gave it to us. Okay, done. I marked it. Then it says BD, that's a segment. Segment BD bisects angle ABC. ABC. BD bisects the angle, you guys. This is the mouth. It's cutting it in two. What that means, okay, actually, because it bisects, I'm going to put this in a different color. And the reason why is because they did not tell us that ABD is congruent to CBD. What they said was that BD bisects. We're going to have to make the mental jump of the definition of bisect, and we're going to have to write that these two are congruent. I'm putting it in a different color because anything that I put in a different color is not going to be given, and it's something we're going to have to add to the proof. So 1 is given. 2, you're going to put BD bisects angle ABC. Why? Given. Okay, then 3. 3 is what you're going to add to this. Okay, so take a look. Can we prove these two triangles are congruent? What do we have? They gave us a side, and we figured out this angle, and look, they have a third side right here. They share a side. This is where I was telling you you're going to have that weirdo statement of BD is congruent to BD because you have to state it because it belongs to both triangles. Okay, so here we go. Number 3. We are going to say angle ABD is congruent to angle ABD is congruent to CBD. CBD. And then you want to say definition of angle bisector. Then for number 4, you need to state that BD is congruent to BD. Only because we're going to use it as a segment for both triangles. And this is what I was telling you, the reflexive property of congruence. Okay, and then 5. Can you state that the two triangles are congruent, and by what theorem? Okay, I'm going to say the triangles, I'm going to put it in their order. Triangle ADB is congruent to triangle CDB. See how they both have DB? That's why we had to put it there. Okay, 5. Side, angle, side. SAS. Okay, so you get the idea. They're going to give you some clues. You got to mark it up, and then you should have enough information to finish the proof. All right, this is not about proving. This is about being able to see things, okay? And sometimes it's hard to see the triangles in the picture. Some kids are better at it than others. Can't tell you why. It is what it is. So when you're looking at the original picture, look, this is a triangle here, okay? And this is a triangle. So they share a piece of a side, but not even a whole side, you guys. But they've combined these triangles, okay? So one of the techniques to work with these things is to separate them, okay? So look what they did. They basically separated the two triangles. They pulled them apart, okay? And they're saying, now you need to complete this. Now, I don't have all of the things here, but I don't think they're going to be hard once you separate them out, okay? Again, I highly recommend, ooh, let's not do that. Let's go to that. Let's go to that, the pen. And hey, let me go with this. Okay, let's go with this. So I highly recommend you do this. 1, 2, 3, and 1, 2, 3. Like you take them out and then you start writing on them, okay? So you're gonna, this is 8, 10, look, 8, 10, 11 is not part of this triangle. Neither is 9 or 1 and 2. We want to go to 3. 3 is here. Okay, what letters are here? T, U, X, and then what's the tip of this guy? W, Y, Z. And what numbers? 4, 6, 1. 1 is on the inside. That's what you want. So you can see that 11 and 9 are marking angles, but they're not important to this problem. Okay, so it says fill in the missing vertex labels. So here you would put T, U, X, and here you put W, Y, Z. Okay, do they have a common side? It does ask you this. Do they have a common side? They don't have a common side, you guys. And the reason why is because it's not a complete side. They have a common, you can let me know, but I'm pretty sure the answer to that is no. They do have a common edge, a piece of a side, but not a whole side. Okay, I don't know. That's interesting. I'm not sure how it's going to answer that. Okay, here we go. Okay, take a look. This is off. This one kind of reminds me of like an IQ or like a puzzle thing where they're like, how many triangles do you see in this picture? Okay, how many triangles do you guys see? Look, there's one little one. There's the medium-sized one. Another little one. That's 1, 2, 3. There's another one here and another one here. Okay, they want you to look at triangle ABD and CBD. So find that. A, and you can trace it. ABD. And if you guys can't trace it, because you can't do that, copy it on your paper. And you want to copy it like they did it. Okay, ABD and CBD. Oh, CDB, sorry, CDB. They said, boom. Okay, those are the two triangles. So I took the red one out and it's here, and I took the black one out and it's here. Okay, so you're supposed to fill it in with the missing vertex. So this is going to be A, because A is here, B is here, and D. And this one is going to be B, C, D. And now if they ask you on this triangle, do they share a common side? And the answer is yes, they do. They share BD. Do you see it? It's right here. So these guys do share a common side. Okay. All right. So in this proof, by the way, like if you were trying to prove that these two triangles were congruent, look, this would be congruent to that because it's the same side, BD, BD. You can actually even see it. It says BD and BD, same letter, same side. Okay. And they haven't given us anything else, so never mind. But you would be able to at least state that because they share that side. Okay. Next. Okay. It says, here's in this particular one, they're asking us whether or not we can use the HL theorem. I think you guys are going to be fine with this, but I just included it just in case. Remember, to use HL, you have to have a right triangle. Okay, so right away, this is going to be no. There's no right triangle. Okay, see? That's no. Now the other three are. So all you need to identify is, did they give you the hypotenuse and a leg? The hypotenuse is this side, opposite the right angle, the longest side. Well, look, these guys share it. Therefore, the hypotenuse is in common. So they have a hypotenuse and a leg. And the answer is yes. These guys didn't give us the hypotenuse. This one is not, doesn't say that they're equal. So this one is no, we cannot use it. This one is no, because it's not a right triangle. And this one, they gave us a leg. By the way, both sides are called legs, and that's the hypotenuse. So you have two legs and a hypotenuse, okay? And they gave us a hypotenuse. So the answer for this one would be yes. Okay. Okay, so look, this one is measures of isosceles and equilateral. All right, couple things you need to know if I haven't given this to you in class in notes. You need to know about isosceles triangles and you need to know about equilateral triangles. Now we talked about them already and what their definition is. An isosceles triangle is a triangle in which these two sides are congruent. Okay, it can be acute and it could be, or it could be obtuse, right? Okay, that's an isosceles triangle. Here's what you need to know. You can write this down. Okay, you need to know that the base angles of an isosceles triangle are congruent. Why would they be congruent, you guys? If you think about it just for a minute, if we hold these sides the same, okay, it's going to force this situation to happen because the sides are the same length. It's like holding some chopsticks at the end and opening up and closing. That's an isosceles triangle situation, okay? I say that because I assume you guys have played with chopsticks like that before, okay? If not, do it, okay? So base angles, these are called base angles because we imagine that the isosceles has a base. This is a base, okay? That's a base. This is called the vertex angle. So we have base angles. So base angles, I'm going to actually erase that so I don't use, I like using shorthand, but base angles of isosceles triangles are congruent. All right. meaning this is congruent to that. This is congruent to that. They're not congruent to each other, okay, just in the triangle itself, okay? When you have an equilateral triangle, that's a whole different situation. Yes, it is isosceles, but it's equilateral. It means all three sides are equal. In that case, think about this. All of these angles are going to be equal too. And what are they going to be equal? Well, if you know that three angles add up to 180 and they're all the same, I could put 3x, if I call this x, I add them up because x plus x, right? They're all the same, equals 180. I can divide by 3 and I will get 60 degrees. Okay, so the angles in an equilateral triangle are 60 degrees. You can write that. Angles in an equilateral triangle are 60 degrees. Again, this is something you need to memorize or have it written down so you can access it. It's really easy to memorize this stuff if you think about it in the real world or play with like some sticks or something so that you comprehend it a little bit more realistically. Okay, take a look. Find the measure of angle V. All you have to know is that this is an equilateral triangle, therefore it's 60 degrees. This is an isosceles triangle, and if this is 35, W is also 35, which means what is X? Well, 35 plus 35 plus X is equal to 180. Combine like terms, 70 plus X equals 180. Subtract 70, you get 110. So X is equal to 110. So you're always going to be using that whole 180 thing, okay, that we've been working with. All right, next. Okay, sharing the side with another angle. So notice, this is an isosceles triangle, and this is an isosceles triangle. Okay, it says find the value of X. All right, so it might seem impossible at this point because you're like, how do these even relate? So again, remember, go back to my dominoes analogy. You can only look at what you have at first starting, and then you look to see what can you tell? What can you knock down? You have one value, 32 degrees. All right, you may not know where that's going to take you, but you can easily mark something else that's 32. This is 32, right? Why? Because base angles of an isosceles triangle are congruent. All right, so now we've got that. Okay, what else could we find? Like, oh, wow, well, okay, good. I knocked over the first thing. What else could I find? Well, don't tell me X is 32. There's nothing that says two angles next to each other are 32. The only way you would know that is if somebody told you that this segment was a bisector, and nobody said that. Okay? But we can figure out this angle. We can figure out this angle because we know the two base angles. So we know that 32 plus this angle here. Okay, I'll call it X because, no, I won't call it X. I'll call it Y. Y equals 180. Do you see why? Look, see, 32, 32. 64 plus Y equals 180. Subtract 64, which I can't do in my head, so I'm going to write it. But if I write it there, I have to write it here, and I need to put a minus sign. 10 minus 4 is 6. 7 minus 116. Okay, so now I know that this is 116. Well, big deal. What can I do with that? Okay, you're like, oh man, what do I? But you can do something with it. Because look, this is a line. You see it? What do we know about this line? We know that we can figure out this angle. Okay? Why? Because a line equals 180. So 180 minus 116. Okay, and we're going to get 64. I hope you guys realize that. Okay, 64 degrees. Okay, so this is 64. Oh, check it out. If we know that this is 64, what else do we know? Because it's isosceles. This is the base of the isosceles, so this base angle is also 64. So what is X? 64 plus 64 plus x equals 180. This is how we have to solve it, you guys. 128 plus x equals 180. Then we're going to subtract 128 from both sides. And you're going to get x is equal to 52 degrees. All right? So x is equal to 52. So check this out. It didn't look like they gave us enough, but all we had to do was start knocking over dominoes. We may not, like, in other words, we wanted to get from here to here, and we couldn't really see. Like, there's a bunch of trees in the way. You know, you're like, is that a tree? Yes, it is. Watch, ready? I'm going to make it into a tree. And that's a tree. Okay, see? There. I made these into trees. They're funky looking trees, but nobody said they had to be perfect. All right, so you can't really see where you're going. So you're dodging things and you're getting along the way and you're like, okay, this second, and then you're like, oh my God, I made it. And that's kind of how it feels here. You just kind of got to follow your nose. Let's try it again, okay? You can pause if you want to. Okay, look. And then if you came back, I'm going to do it. This is an isosceles triangle. This is 31 as well. 31 plus 31 plus, let's call this, what? I don't care. I'll call it y again. Y equals 180 because this is a triangle. 62 plus y equals 180. Y is equal to 180 minus 62, 118, I believe. Yeah, you can do it with the calculator, it's fine. Okay, so y is 118. Then you could find this angle. Okay, let me switch colors because I'm going to a different triangle. So 180 minus 118 is equal to 62. That's equal to 62. Okay, then this is equal to 62. Okay, sorry. Let me, just a sec. Sorry, my daughter is messaging me. Okay, hang on, there we go. She's actually FaceTiming me, but I'm not going to answer because I need to finish these notes. So 62 is 118. We're so now we can add them together. 62 plus x equals 180. That's 124 plus x equals 180. X is equal to 180 minus 124. 56 degrees. Okay? All right, next one. Finding the angle measures of an isosceles triangle given angles with variables. All right, so now we're getting to some algebra stuff. They're trying to remind you, you need to write the equations that go with this. I wish I could say you don't, but you do, okay? It says, suppose that DEF is an isosceles with base EF, okay? So here's my base, EF. What do we know about base angles? They are congruent. I'm marking it because that's important, okay? Now they're just telling you what's in the picture. D is equal to 2x plus 66, and E is equal to 3x plus 29. I'm not sure why they're putting parentheses. I think because they need to put that degree, and they can't actually do it. If they put 3x plus 29 degrees, it would mean that only the 29 had the degrees. So I think that's why they're putting the parentheses. But when we're working with it, I want you to know that you can take it out of parentheses because you can't work inside parentheses. You have to get rid of them. So we're going to take them out, okay? It says find the degree measure. Be careful. Find what? The degree measure of what? Each angle in the triangle. So what do you know? You know that this one is also 3x plus 29. These are equal. So I'm going to actually simplify it. I'm not going to say 3x plus 29 plus 3x plus 29, although that's fine. I'm going to use the distributive property and go 3x plus 29 times 2, because there's 2 of them, plus 2x plus 66 equals 180. See, I'm just adding all 3 angles, and they equal 180. That's how we're going to solve this. 6x plus 58 plus 2x plus 66 equals 180. Combine like terms, 8x, numbers, combine them. 58 and 66, 8 plus 6 is 14, carry the 1, then you've got a 6 and a 6 is 124. Equals 180. Now we need to subtract 124. And again, this part, I really don't need to show it to you, but I am just in case some people are still struggling with their algebra. 56, x is equal to 7. Yay, we found x, but that isn't what they asked us. They asked us to find the degree measure. So we have to go back and plug it in. 3x plus 29, 3 times 7 plus 29. That's 21 plus 29, which is 50. 30 plus 20, yeah, 50. So this E and F are equal to 50. E is equal to 50, F is equal to 50. Then you have 2x plus 66 formula, substitution, resolution. 80. And then you have to ask yourself, does that add up to 180? If this is 50 and this is 50, does it make sense that this is 80? Yes, it does. Okay, next, you can shut this off if you want, like pause it. Okay, and see if you get this right, okay? Take a look, they flipped it. These two are congruent, okay? They want you to find the degree measure of each angle, okay? I don't actually read all this stuff because it's basically just telling me what's in the picture. But if we know that these are equal, listen to what we said. Base angles are equal. Don't be setting them equal to 180. That makes no sense. They're equal to each other. So we are going to make them equal to each other. Okay, and now you're going to solve. You need to get the x's on the same side. So I'm going to subtract 4x from both sides. I'm going to get x minus 26 equals negative 11. Don't forget to carry down the negative. I'm going to add 26 to both sides, and I'm going to get x is equal to 15. Plug it back in. 5x minus 26. I'm sorry, I wrote that wrong. 5x minus 26. Formula, substitution. 75 minus 26. 15 minus 6 is 9. I dropped that down to 6 minus 49. Okay, check it. If you did it correct, when you plug it into this one, it should be the same because these are base angles. Formula, substitution, resolution. Yep, they're the same. So the answer is 49. Okay, oh, but it wants you to find D now too. Okay, well then 49 plus 49 plus angle D equals 180. And I'm going to leave that to you. You can figure that out. Okay, and that's it for these notes.